Welcome to Calculus. We conquer our fears and flex in the face of adversity. On this episode, Stevenson will demonstrate
In this first example here, it says that given f of x equals this polynomial, find the derivative of the inverse of f evaluated at 3. So the first thing that I suggest doing is making sense of the connection or the relationship between this 3 on the inverse and what does it correspond to on the f of x. So here's how I do it. I kind of came up with this weird kind of structure. So what I do is I ask myself, okay, if I'm focusing on my inverse, 3 is my input on my inverse, so it's going to have some kind of output, right? I don't know what it is yet. But what I do know is on the f of x function, where it comes from, these points switch. So this means the input of 3 on the inverse actually represents the output on my f of x function. So I'm trying to figure out, well, what is it that I put into f of x, which gives me out 3? Because remember, these ordered pairs interchange on my inverse. Well, this means the output of f is 3. So I need to find out, so when does f of x equal 3? So essentially, I need to take this polynomial, set it equal to 3, and solve. Well, luckily for us, we can use our handy-dandy calculator. So the first thing I want to do is graph my polynomial. So here's my polynomial. Now, I want to know when does it equal 3. So I'm going to graph a second equation. I'm just going to type in 3. Essentially, what I'm going to look for is where do these intersect. So I'm going to go zoom standard. I'm interested in that exact point there. I want to know what input gives me an output of 3. So setting this equal to 3, the easiest way is to use the calculator. There's probably algebraic ways to solve it, but this is the fastest way. So now I'm going to calculate the intersection. So I'm going to go second and then press the trace button so I can activate the calc feature. And I'm going to go to intersect, number 5. When you do this, the calculator is going to ask for 2 things. It's going to ask you to determine or designate what's the first curve, what's the second curve. It doesn't matter which one's your first, which one's your second. All you need to know is use your up and down buttons here. Use your up and down buttons right here so you can go between your 2 curves. So it automatically defaulted here, that's fine. So I'm going to say the first curve. Now, if it's not in color, it'll tell you up top here what the curve is. So I can see this is on the polynomial. So that's my first one. I'm going to press enter. And then notice the cursor automatically jumps to the next available function. So in this case, it happens to be my second. And so I'm saying, hey, is this your second curve? I can see it's my constant. So I'm going to press enter again to say yes. Now it's going to ask you to guess where you think the intersection is. So you don't have to do this, but you could move the cursor over like this and go, it looks like it's about there. And then you press enter. It's thinking, look, so there's my intersection point. So the output is 3. So again, when is the output 3? The output is 3 when x is 1. So I now know what this point is. So when I put in 1 into f, it gives me out 3. Well, that means on my inverse, if I put in 3, I would get out 1. Now you may be wondering, Stevenson, why do we need to do all that? Remember, what are we trying to find here? We're trying to find the derivative of the inverse of f at 3. Well, what that means now, remember the formula. So if this is 3 on the inverse, then that corresponds to 1 over the derivative of f at 1. So this little scratch work here helps me understand what are the points I'm looking for. So if I want the derivative of the inverse of f at 3, I'm going to calculate what's the derivative of f at 1 and do 1 over that. So off to this side. So what this tells me now, this is 12. So I can do my final answer. There it is. Easy peasy lemon squeezy. Let's look at another example. So this time, given g of x equals cosine of x plus 3x, find the derivative of the inverse of g evaluated at 1. So just like in the previous example, the first thing I want to do is try to make sense of the problem. So the input of 1 on the inverse represents the output of 1 on G. So what I want to do now is figure out when is g of x equal to 1. So I'm going to follow the same thing I did before with my calculator. I'm going to graph the function itself, and then I'm going to graph a horizontal line of 1, and then I'm going to look and see where they intersect at. Now, because I have a trig function here, I do recommend doing zoom trig this time, because sometimes that can help us with our interpretation of the graph. Now I have my graph, so I'm going to try to figure out where it intersects. Now, I'm looking at this, it looks like it could be that y-intercept of 1, but I'm going to do second calc just to make sure. Now, I can see the intersection, it is telling me it's 0, 1, so this means when 0 goes into G, out comes 1, which means on my inverse, when 1 goes into the inverse, out comes 0. I now know my relationship between the 2 points. Now I can go to my formula. Now that I know I need to find f prime of 0, off to the side, I'm going to do my work. Now that I know what g prime of 0 is, I can now complete my answer.